Hey students, this is lesson 121. It's a lesson about slope. We're going to learn how to calculate slope and understand it as a constant rate of change in a line. I'm skipping ahead a little bit here, and we'll go back and do the other parts of class, but I'm going to start right here on page 3. So find this page. You can see a little picture of a caterpillar running up a slope. The slope of the hill is really how steep it is, and you can show that a couple of ways. You can use it as you could probably find it using an angle, but the way we're going to do it is by using a ratio of rise over run. The more rise you have compared to the run, the steeper it'll be. So the ratio of rise over run is also used to describe the steepness of a line. The ratio of rise over run for a line is called the line's slope. And just think about this, if we extended the rise, right now when we do rise over run here, we get 40 divided by 100, which is 0.4. If we extended the rise, that would create a line that's steeper for that caterpillar to crawl up. And that would be, so we end up with a ratio that's higher. Check that out. So the more rise you have compared to the run, the steeper the line. It's a good way to show the slope. All right, so we're going to learn how to find the slope on a coordinate grid. So first of all, let's look at this little problem here, and let's write down the coordinates of point R and the coordinates of point S. Remember, the first number is the x-coordinate, so for R that would be 1. And the second number is the y-coordinate. For R that would be 6. And then S is the points 4 and 12. And we want to find the slope of the line. Now, slope is the ratio of rise over run. And if we just find it like we did with the caterpillar problem, we can just look how much rise there is from R to S, which is right there. And if we count on the grid, here we'll just go 2, 4, 6. So this represents 6 there. The rise is 6. And the run is going from here to here. That's 1, 2, 3. So that's 3. When I divide those two, I get 2 for my ratio. Okay. Another way we can find that slope is by subtracting the coordinates, and I'll show you that here. Now imagine, check this out. If this point S here is at 12 right now, right? And this point R is at 6. And I can always find the distance between those two numbers by subtracting them. So I can do 12 minus 6. And that gives me my rise, which is 6. Similarly, I can look at the run of these 2 points by looking at these two numbers, 4 and 1, and just subtracting them. So 4 minus 1 equals 3. And that's my run. 6 is my rise. So I can always get my rise and run from the coordinates. So that's what we're going to do here. We're going to find the rise by subtracting the y-coordinates of point R from the y-coordinate of point S. Let me write these down again. R was 0.1, 6, and S is 412. And remember, they go in alphabetical order. We have X and then Y for our coordinates. Okay, so we're going to find the rise by subtracting the Y coordinates, and you always subtract the Y coordinates to get the rise. So we're going to do 12 minus 6, which is 6. We're going to find the run by subtracting the X coordinate of point R from the X coordinate of point S. So we're going to do 4 minus 1, which is 3. And then we're going to calculate the slope by doing rise divided by run. Rise was the difference in my y coordinates. Run is the difference in my x coordinates. 6 divided by 3 equals 2. Now, 11 says, would you find the same slope if you subtract the coordinates of point S from the coordinates of point R? Try it and see. In other words, we're just going to go backwards. We're going to do 6 minus 12. So let's try it here. So rise is 6 minus 12. Run is 1 minus 4. I want to divide those two, so I'm going to do 6 minus 12 is negative 6. 1 minus 4 is negative 3. Negative 6 divided by negative 3, and you can check this on your calculator, but remember, negative divided by negative is positive 2, so we get the same thing. So it didn't really matter which way we subtracted the two coordinates. Now, would you find a different value for rise over 1 if you used a different pair of points on a line? The rise over run is the steepness, and on a straight line, the steepness never changes. So we're going to say, no, you never would. The slope is constant on a straight line. Okay. Adam calculated the slope of a line as negative 2. His calculation is as follows. Rise, he did 12 minus 6. Run, he did 1 minus 4. So he did 6 divided by negative 3, and he got negative 2, which is different than what we got. Do you see his mistake here? On the first one, he took the y-coordinate from point S. I believe that was S, yeah? And then he subtracted the y-coordinate from point R. But on the bottom, he did the y-coordinate from point R and then subtracted the y-coordinate from point S. You can't switch those around like that. So that was his mistake. He switched. The points for the run. All right. Okay, we're going to do one more thing here. We're going to calculate, we're going to use our little process of subtracting coordinates to find the rise over run. So write this down here. We'll do number 15. We're going to do, and this is a little formula you can keep. Remember, slope is rise divided by run. And you can find the rise by subtracting the y-coordinates. And there's 2 of them, so I'm going to label them the second y-coordinate and the first. And it wouldn't matter if you had a 1 and then a 2 there. However you want to do those. Okay, so now I'm going to take my y-coordinates from my points in number 15, and that's, I'm going to underline those in blue. That's the 4 and the 2. So I'm going to do 4 minus 2 for those. And then my x-coordinates are the red ones, and I need to do them the same way, so I need to do the negative 3 minus negative 7, and that equals 2 over 4, which is 0.5. And just I'm gonna go ahead and graph these and just check that quickly. So my point is negative 3, 4. There's one point. Negative 7, 2. There's the other point. I'm going to draw a line through those. And this is an increasing line. And I'm just going to check it by using the graph. Every grid here is 1 unit. So if I go up to this next point, I have a rise of 2 and a run of 4. And 2 divided by 4 is 0.5. So that slope is 0.5. And that checks. All right. We're going to do the rest tomorrow. What I'd like you to do is go ahead and find the slope on 16, 17, and 18, and be prepared to share those with your group. See if you can use this formula consistently. See you tomorrow.